Today's lesson should help you prepare for the titration lab that our class will be completing this week. It is important to understand some of the terminology associated with titrations. When we titrate, the titrant is the solution that is added to a burette, and the sample is typically in an Erlenmeyer flask below it. We will know the endpoint in our titration because there will be a color change. In titrations, we add titrant until we notice a permanent color change. The color change occurs because there is an excess of titrant that has been added to the sample. Our target in titration is to stop titrating as close to the equivalence point as possible. The equivalence point is where the number of moles of the reactant in the sample has been used up. Our endpoint is when the next drop of excess reagent is added. This one drop between the equivalence point and the color change should be your endpoint. In redox titrations, we will be using strong reducing agents or oxidizing agents as our titrants. There is usually an unknown, which is a reducing agent, and a known, which is the oxidizing agent, that shows a different color when it changes oxidation state. The known titrant will change color when the endpoint is reached. Here are the half reactions for some commonly used titrants. In acidified solutions, permanganate ions change from purple to a faint pink or almost colorless color. In acidified solutions, dichromate ions will also change color. They change from orange to faint green. In both cases, as soon as the final drop is added, the color change will be observed and the chemist will stop titrating. Standardization is a process that is used to determine the exact concentration of a titrant. Before we titrate to find the concentration of an unknown solution, we need to know what the concentration is of the titrant we are using. A primary standard is a solution whose concentration is precisely known. In this example, potassium permanganate is the titrant that is used to determine the concentration of a sodium iodide solution. In redox stoichiometry, we need to determine the balanced equation before we can begin our calculations. The first step is to identify the entities and then determine which are the strongest reducing and oxidizing agents. Using the half reaction for the oxidizing and reducing agents, the net reaction is written. This reaction will be used in our stoichiometric calculations. We will calculate the number of moles of permanganate by using the concentration and volume. The next step requires use of the balanced equation to determine the mole ratio of iodide ions to permanganate ions. Next, the concentration of iodide ions can be calculated from the volume and the number of moles. Please complete the October 15th quiz.